And now let's talk something about the ordinary nonlinear programming problems, because the linear programming and quadratic programming are special cases of this kind of ordinary nonlinear programming problems. And standard form of nonlinear programming problem is like this. And in our last lecture, we talked about the optimization problems in control. Because we didn't pose any constraint on the variables, we can find and we can convert the original controller design problem into an unconstrained optimization problem. However, in control, sometimes there might be constraints. For instance, if we want to design a controller and to assume that the overshoot of the output could not be too high. For instance, we can require that the percent overshoot is less than 3%. So this is actually a constant. So we can add this kind of constant to our control problems, or other application problems. So constant problems are also very useful in scientific research, and we can use this kind of constant. We can introduce constraints to improve our design. And we can further rewrite the original problem like this. And this one is remain the same, it's still the same as the one in the standard form. And we can rewrite the constraints like this. And we can extract the linear constraints, and then we have nonlinear inequalities and nonlinear equalities. And it should be noted that for the nonlinear constraints, the right-hand side should be 0. So we have to move everything to the left-hand side. So these are the standard form in nonlinear programming problems. Now, how can we solve that one? We can call a function called fmin con to solve the problem. And we have to write a Matlab function to describe the objective function because it is linear. No, it is nonlinear. So we have to rewrite it using a Matlab function to rewrite it. And we have to specify an initial searching point. And also we have to write a Matlab function. And this function should return these two variables instead of one variable. It should return two variables. One for inequality constant and one for equality constant. And then we can solve the problem immediately. So let's solve a particular example using Matlab first. Suppose we have a nonlinear programming problem like this. And in the programming problem, it seems that this one is a quadratic programming problem. Actually, it is not, because there is nonlinear constraints there. So now what we need to do is to design a Matlab function. And for the objective function, we should design a Matlab function in two ways. One is to write a .m file. The other one is use the anonymous function. These two ways work well, should be the same. To express the objective function. And what about the constraint? We can regard this one as a nonlinear constraint. So what we need to do is to write a Matlab function. We cannot use the anonymous function to describe the constraint here, because you must have two return variables. One is C, the inequality, and then the other one is CEQ. You have to return these two variables equal to a function name. X. So this is the standard form to describe the constraint, nonlinear constraint. And for this particular example, because there is not a inequality constraint, so we have to assign C equals to an empty matrix. But we have to write this one, we cannot omit it. If there isn't a inequality constant, we have to assign a variable C because we have to return it some way. So we have to assign it as a empty matrix. And then we can write CEQ equals to x1 squared plus x2 squared minus 35. So this is the constraint function we have to write. The first one should be the objective function. We can write it out directly. And we have to do this kind of preparation first. And also we will notice that this one is a linear equality. So we can assign AEQ and BEQ from it. It should be AEQ equals to 8, 14, 7, and BEQ should be 56 from it. And there isn't any linear inequality, so A equals to empty matrix, B also equals to an empty matrix. So what you need to do is to do this kind of preparation. So this is a program. This is a command I have to use. We have to write a function to describe the constraints first. When the return variable C is an empty matrix because there isn't any nonlinear inequality in the constraints. And also we have to describe the objective function f. So this is the f. So we have to assign. So this should be all the command we need actually. Okay, well there. This is the command we must use to assign the objective function. This is the objective function. And this command should be used to solve the whole problem. We have to assign AEQ and BEQ and select an initial search point, then we can solve directly. So this is the final result. And the value of C is 4. It's still larger than 0, so it means that the result is acceptable. So this is the optimization result that we finally obtained. And this is the objective function minimized. For the same problem, let's consider it again.